Neural networks power everything from ChatGPT to self-driving cars. They can recognize faces, translate languages, and generate art. Yet at their core, they're just matrix multiplication, addition, and one clever trick. Let's build one from scratch. Welcome to episode 13, the beginning of deep learning. We're building a neural network from the ground up. No libros, no magic. Just pure understanding. A single neuron takes multiple inputs, multiplies each by a weight, sums them up, adds a bias, and passes the result through an activation function. That's it. The weights determine how important each input is. The bias shifts the output, and the activation function adds nonlinearity so the network can learn complex patterns. Stack neurons into layers and you get a neural network. The input layer receives data. Hidden layers process it through weighted connections. The output layer produces the final prediction. Data flows forward through the network. This is called forward propagation. Each layer transforms the data, extracting increasingly abstract features. The forward pass in math. For each layer, multiply the input vector by the weight matrix, add the bias vector, and apply the activation function. Layer 1 takes the raw input and produces hidden features. Layer 2 transforms those features further. The output layer produces the final prediction, either a number for regression or probabilities for classification. After the forward pass, we compute the loss, how wrong the prediction is. Then backpropagation kicks in. Using the chain rule of calculus, we compute the gradient of the loss with respect to every weight in the network. Starting from the output layer, gradients flow backward through each layer. Each weight gets updated proportionally to its contribution to the error. The chain rule makes backpropagation possible. The gradient of the loss with respect to any weight is the product of local gradients along the path from that weight to the output. We compute the output error, then propagate it backward, multiplying by activation derivatives and weight matrices at each layer. This is elegant, efficient, and the reason deep learning works. The full training loop. Feed a batch of data through the network. Compute the loss. Backpropagate to get gradients. Update all weights. Repeat for thousands of batches across many epochs. Slowly, the network's weights converge to values that minimize the loss. Monitor validation loss to catch overfitting early. You just build a neural network from scratch in your head. Forward propagation, backpropagation, and the training loop. Next episode, convolutional neural networks, how AI sees images. Subscribe.